We want to prove that this angle, A, is congruent to this angle, C, given this rhombus. And we know it's a rhombus because they told us that side AB is congruent to BC, is congruent to CD, is congruent to DA or AD. So it's a rhombus, it's a four-sided figure, and all the sides are congruent to each other. So we want to prove that this angle is congruent to that angle. The hint that I gave you was to draw a line. And you can draw lines anywhere on this, but the one that's going to help us is this line right through there. Because as soon as we draw that, we've created two triangles as part of that rhombus. Now let's do a technique that's called extracting the triangles. And by that I mean I just want to visually take this apart so that I can see the triangles that I'm dealing with. So here's A, B, D, and we know that these two sides are congruent. And here is the other one. And notice I'm trying to draw them about the way that they are visually in the full diagram so that you're not trying to mentally twist and turn them all. So we have this triangle is extracted down to here. This triangle is extracted down to there. And what we see right off the bat is that this is an isosceles triangle and that is an isosceles triangle. Now we can't assume that they're congruent just by knowing that they're both isosceles, not even by knowing that these two sides are congruent. But what we do know is that this side BD is this side, and we don't know what its length is, so we mark it down as separate from these two. But we do know that side BD is congruent to side BD because congruency of line segments is reflexive. The line is congruent to itself. And now that we've pulled it apart, then really what we're saying is this line's congruent to itself. When we pull it apart, now we're saying the line segments we have two of them, and so now its line segment congruence is symmetric. This line segment is congruent to that line segment. So now look at what we have. If we match up this side and we say it corresponds to that side, and we say this side corresponds to that side, and this side corresponds to that side. So let's write it down. AB corresponds to BC, and AD corresponds to CD. And then we know that BD is corresponds, we'll call it DB just to make sure that we're thinking about two different diagrams here. But we also know that AB is congruent to BC, that AD is congruent to CD, and we know that BD is congruent to DB. So we've set up the corresponding sides. We've shown that the corresponding sides are all congruent, and we say, therefore, by the side theorem, so we say by SSS, the triangles, so we'd say triangle ABD is congruent to triangle BDC. And because they're triangles, and because they're congruent, that means the corresponding angles are all congruent. And so we were trying to see if this angle A is congruent to that angle C. A is is this angle. It's between BA and DA. C is between CB and CD. These are corresponding angles, so we know that they are congruent. So sorry I didn't write that up here. I should have, to make my logic nice and even. But then I can say, therefore, angle A is congruent to angle C, QED. We have proven what we've set out to prove. If these two triangles are congruent, then their corresponding parts are congruent, and angle A is between these two sides, angle C is between the corresponding sides, and so therefore they are congruent.